Hi, everybody. It's Jason Fraser, meteorologist from WKYC. Want to thank you once again for tuning in to this weather lesson. And today we're going to be talking about weather radar. But as always, I like to start off with something funny. And here's my joke of the day. What type of cloud is so lazy it doesn't even like getting up in the morning? Are you ready? Here's the answer. Fog. Get it? Because it stays on the ground. All right. All right, so as always, I love your weather questions. You can feel free to leave a comment on this video right there, or you can always email me at jfraser@wkyc.com. That is JFRAZER at WKYC.com. Let's get this weather seminar started. Today, we're going to be talking about radar, how it works, and what are the different types of radar, and how you can spot a storm on radar. So first, what exactly is radar? Well, radar, just so that you know, is an acronym. It's not actually a word. Radar actually stands for radio detection. And it was based on an idea by this lovely young gentleman that you see right here. His name is Heinrich Hertz, and he basically believed that radio waves could be reflected from metal objects. He thought that if you send out a radio wave, it would boop, it would bounce back. Well, it's interesting because radar wasn't originally created for weather. It was actually created by people in the military to see other ships. What happened was they were out and about, they were doing their thing in the ocean, doing a little bit of spying on a couple of other people, and they wanted a way to figure out how one ship was in one place and another. And they also wanted to figure out how they could see planes from the air because depending on the weather, it could hide some of the planes. And if you're in the middle of a big fight or a big war, you want to know exactly where your enemy was. Well, the interesting thing was, as they started creating this thing called radar, they started seeing other things pop up on the screen. So, is that rain? Is that snow? Well, they actually figured out that the early radar started to pick up on several different things like rain and snow. Now, how radar works is pretty interesting. Okay, it basically works like this: it sends out a beam, and then that beam hits something and then is reflected back. The best way to describe this is if you've ever played handball with a wall, right? You send the ball out, you throw the ball, and then the ball bounces back to you. Now, depending on how close you are to that wall, is how fast that ball bounces back to you. And that's pretty much what happens with radar. Now, depending on what the signal that is sent out, depending on what that thing that it hits and how quickly it hits, is what color that we see on radar. So as you can see here, the greens, well, those are representative of some rain. And if you look right here with the yellow, that is likely either some thunderstorms or some hail. So it really depends on what radar you're using and what colors correspond to that. Now, the cool part about radar is it sends out a signal and it bounces back. So the best way to describe this, and this is something that you can try at home, where if you took a cup and you started talking in the cup and your voice sounded like this. Well, the reason why your voice is sounding like this is because your sound waves are moving to the bottom of the cup and they're bouncing back. That's pretty much how radar. Now, radar is also pretty cool because the longer that those waves are sent out, the farther the wave has to travel. So the cool part about radar is it can tell you where the storm is in comparison to where the radar is. Now, the original radars, I'll just say they were pretty old, and they couldn't really tell us a lot of information about some storms. So they couldn't tell us how fast the rain or the snow is falling or how fast the winds are. we could only basically see where the storm was, and we could make a pretty good guess on where the storm was going next. Then this thing called Doppler radar was invented, or the weather surveillance radar. In some pieces of literature, you might see it referred to as WSR-88D, right? Kind of sounds like a top secret weather instrument. It's actually not. It's just what they decided to call it. It was a very boring name. But the cool part about radar is you could actually see how fast the storms were moving and what was actually in the cloud. And what I mean by that is we could, for the first time, tell the difference between whether or not it was rain, whether it was snow, whether it was hail, whether it was just ice. We could tell that. And we could also get a much better idea of where the storm was. So the interesting thing about radar is you have to have a network of different radar because as you're sending out a beam, it can really only go but so far. Now, then there's this thing called dual polarization radar, or DUPOL. Now, DUPOL is something that is very new. It was only created within the last 20 years. And the issue with the regular Doppler radar is it would send out a signal horizontally, right? You could just send it out that way. Now, depending on where the radar was, sometimes you could adjust the radar beam to maybe go a little bit farther up, but it was only one beam that was going out. So sometimes you would actually miss rain because if the rain wasn't at the level where the beam was, well, it would look like it was not really cloudy outside. So that's why they created this thing called dual polarization radar. And the really cool part about this is, what does the word dual mean? Well, dual means two, right? So with the pulse, it actually would send out two different pulses. It would send out a pulse like this, and it would actually send out a pulse like this. And the reason why sending out a vertical pulse as well as a horizontal pulse was pretty cool is because you could actually see whether or not it was hailing, whether or not it was raining, whether or not it was snowing, how big the system was, how big the pieces of hail were. You could also figure out how much rain was going to be falling. Why? Because we could also now understand how big the clouds were, and we could make some of those estimations as far as how much rain was going to be falling. And we could also pretty much see whether or not it was a bird or a plane or some debris. Because sometimes with weather radar, you get these things that are flying. And as the beam is being shot out, it'll actually pick up on different things. So think of like X-Men, and you remember Cyclops, where he could like, he could send out beam. Well, that's pretty much how radar works. And you and I both know that sometimes when he was aiming at something, he would pick out something else if he didn't have on his special goggles. And that's pretty much how weather radar works. Now, here's the thing about weather radar, and I kind of touched on this before. Radar isn't perfect, all right? Radar is created by human beings. So therefore, there are going to be some things that we're still working on with radar. Now, radar has, when you send out that beam, it can only go but so far, usually anywhere between about 88 to about 115 miles, all right? And that's part of the reason why we have what we call a radar network, right? So after every certain amount of miles, we need to make sure that we have another radar. Now, you might be wondering, well, why? Well, think about it. If I have a storm, I'll use a cup here, right? If I have a storm that's kind of moving like this, right? And I only have a radar that's right here and maybe another one that's right here, eventually that storm's going to move away from a place where I can't actually capture it on my radar. So that's why all of the different weather radar systems that are designed by the National Weather Service are all strategically placed so that for the most part, we can actually see everything that happens in the United States. Now, there are some places around the country that don't really have good weather radar. And part of that has to do with where it is. So if you have a place that's really, 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 really far up, like on a mountaintop, it's really hard to see what's happening around there on weather radar unless you have either a dual pole radar or you have a radar that's all the way up at the top of the mountain, and that's pretty rare. Now, the other limitation on radar is sometimes, and you'll actually see this here in Cleveland and other parts of the country, on a clear, crisp day where there is no rain or anything going on, sometimes you can actually pick up either debris or birds or other things. Sometimes, if you get a really bad fire, you can actually see the smoke come up on weather radar. And so sometimes if you're not trained, you have to be able to tell what the difference is between rain as well as debris. The other thing is with radar, it's not always instant. So depending on how close your storm may be, sometimes it'll take it a little bit longer for that information to come back. And depending on what's happening, right around that time, well, you may need that information right away. So, for example, if there's a tornado that's on the ground, guess what? We want to know that information right away. But sometimes with weather radar, it's a little bit of a delay because, again, that beam has to go out and then it has to hit something and then it has to come back. And depending on what it's hitting, it may take a little bit longer than normal to come back. All right, so I've thrown a lot of information at you about weather radar. So tomorrow we're going to be discussing a little bit more about radar and how meteorologists use radar to determine whether or not a storm is going to be a really bad storm or if it's just going to be just a regular old thunderstorm. We're going to also teach you a few tricks on what to look for on a weather radar. So, what are some things that we look for as meteorologists when we can tell whether or not a storm is going to be really bad, and how you can learn that information to protect yourself? All right. So as always, I welcome your questions, comments, concerns. Maybe you have a long speech, maybe you have a short speech. I always try to respond to every single one of your comments and questions. Feel free to drop me an email at jfrazer@wkyc.com, or you can hit me up on any of the social medias, Instagram, Facebook, Twitter, even Snapchat at Jason Fraser TV. Hopefully you learned something, and I hope to see you soon. Bye.